Hello and welcome to another tutorial. So this time we're going to be continuing to add to the spaceship controller. And the big thing we're going to be adding this time is making it so that we can have gravity that can vary. And not just the strength of the gravity, but the direction. So up until now, we've had gravity always heads down and always at a fixed amount. I want to make it so that we can have an actual planet in there, so that we can fly around it, and the gravity is going to be holding us to that planet, and setting it up in such a way that we could then conceivably have other planets and things like of that, so that the gravity you're experiencing is based upon the combination of things. So there's going to be a bunch of things we need to change for this, and there's going to be some hilarious bugs that we encounter, but we're going to dive in and get this up and running. So, couple of things that we're going to need to do. So I'm going to set this up as another system. Now, one of the things that I have done since the previous video is I have brought in the very latest version of the character motor. So this is the version where it splits it. So we have a player and an AI character motor, which I've just brought the player version in. So that's something that it split that out. So it brings in stuff like stamina and health bars, and brings in a couple of other improvements there as well. So that's been brought in. So that's there in a separate change if you're wanting to see that, but that's split up. So what I'm going to do is I'm going to put in a gravity tracker. So with this, we're going to need a couple of things. I'm going to need the ability to set up a actual thing on an object that is tracking the gravity information. And I want this to be tracked per object. So we're going to have a gravity tracker. And I want to then also have a gravity source. So this is going to be something that creates gravity. And then I'm going to need a way for the tracker to find the sources. So sources are going to be attached to something in the world, and I want it to be easy enough to find those sources. So what I think I will do with this is something where we actually have a gravity manager that we can just ask for the set of sources. So I'm going to also set up a gravity manager. So the source, well, we might have other source types as well. So what I'm going to start out with, and there's different ways we could set this up. So this is something where you could have inheritance. So we could have different types of gravity sources that we get via inheritance. We could have something where we use an enum. There's different ways that we could do this. I am going to actually go for, I'm going to mark this as abstract. And I want this to have a public abstract vector 3, abstract vector 3 get gravity 4. So the idea will be we give it a particular thing and it'll be a position. So that's the sort of setup we want for this. So, okay, that's going to be the common thing we have for the gravity sources. What I then want to have is I'm going to set up a couple of types of sources. So I want a gravity source, and I want something that can just be a global one that's affecting everything. That one is going to be pretty straightforward because that's going to work as our conventional one. And I also want to be able to have a gravity source spherical for something like a planet. So gravity source global, well, this is going to be pretty straightforward. We will have a vector 3 gravity. And so this is going to inherit from our gravity source. which immediately means it's going to be grumpy at us because we haven't implemented that. So we can just tell it to implement this. So we can tell it implement that, which all we would do is, in this case, because we don't care about the position, we just return gravity. So global one is quite straightforward. The spherical one will be something that initially we will make it so that it doesn't matter how far away from the object we are. Now that is something we will absolutely be able to change, and that's something I think would make a good option for the spherical one. So again, we let it implement that. So what we would have is a serialized field, gravity strength, which I'm going to set to 9.81, so the default Earth gravity. And then what this will do for now is we take our transform position, we subtract that position that's been provided, and we normalize it and multiply that by the gravity strength. That's going to give us a force that is heading, or acceleration that is heading inwards towards the center of the sphere. Now, in the case of a real planet, gravity varies based upon our distance from that planet. So that is something that we would absolutely add in eventually. We'll add in some ranges here for the gravity, but initially I just want to keep it simple. We'll just have it as a fixed amount regardless of where we are. And once we've got it up and running, then we'll have the variation happening. So that's good. We've got our setups there. Well, we need to have our gravity manager. So we're going to create our gravity manager, which will just reset the position of that. Not that it matters, but just usually like to have everything organized at a good location. So gravity manager, we want it to be easily accessible. So this is where having it be a singleton is going to be ideal. So we're going to have it that it is publicly gettable, only private settable. We make sure we can't inherit from it. And then in awake, we can go instance is this, but we do our safety check of if instance is already set, then we will return so we don't override it. We will destroy the game object that it's attached to, but before we do, we log out an error. Found duplicate gravity manager on, and we just log out the game object name. Just in case, so it shouldn't, ideally it won't happen, but just as a safety measure. So that's good. Well, what I want this to maintain is I want it to maintain a list that is publicly gettable of gravity sources. All sources. So that is something that I want it to maintain. And in terms of how we register the sources with it, that's something where we could go for a fairly standard approach, where in void start, we go, hey, gravity manager, instance, register this, and then private void on destroy gravity manager instance deregister this. Now we do need to make sure the gravity manager exists in that case. And also I could make these a little bit simpler and just do it like that, so they're just on the parent object, or just on the actual, they're being static functions. So I could set up my static functions here then of a public static register, static void register. and that gets a gravity source provided in. And all that's going to then do is f instance dot all sources. So we check if it contains that, and specifically we check if it does not contain it, then we add it. We don't want to add the same thing multiple times, so just good to check that. And then the deregister, that has to first check, well, if instance is not equal to null, because destruction order can vary, so we need to make sure that we do actually have the instance. So that's good. We've got a way to register and deregister the sources now. So that's excellent. So what I'm going to do is all sources there. I don't want that to be accessible, so I'm going to mark that as a property like that. So it can be initialized, but I don't want it to be in the inspector. And what I'm going to then add in is a global one that is minus 9.81. Because the idea is what I will do first is I want to update the spaceship so it's reading information from the gravity manager and avoid having it that it's, or from the gravity tracker, and avoid having it be using any of the current stuff like vector 3 up or down. So what we will do is the spaceship, which the spaceship no longer requires player input, and that's something where I can update that on the prefab, and we can update this on the prefab. Now there likely will be updates we need to do for things like of the actual follow camera. That is something that will almost certainly change. So, okay, we need to add in a component, and what we're going to add in is our gravity tracker. And so the gravity tracker's job is we need to be able to, at any point in time, ask it for what is the gravity vector. So I want to be able to go gravity vector, go like that. We will default it to 0. I am also going to chuck in a couple of helper ones here, just because these will keep it as sort of short, easy sort of things, where I want to be able to have up, which is minus gravity vector, and down, which won't be minus, it'll actually be that. Just make it so we've got a couple of easy ways of working this out. So that looks good. We've got our vectors that we can be querying for that. So we can now go and start updating the spaceship. So the spaceship, I'm going to require a component, and I'm going to require our gravity tracker, because this is something that has to absolutely be there. And I think it makes sense to have this set up near the rigid body. So gravity tracker, and I'm going to call this the gravity. Maybe local gravity would actually be an appropriate name for that. So then in awake, can go local gravity is equal to gravity. We get the component of the gravity tracker, so we go get component gravity tracker. So that's good, we'll have that retrieved. Now we need to look for anything where we're doing a vector 3 dot up, dot down. Any of those things are something that would be affected by this, because we want to make sure that that is being applied appropriately. So one of the first things we're going to do is for the spaceship, at the moment the rigid body is where gravity is coming from, so we turn that off. So the gravity is now something we have to drive. So we can do a general look through. That stuff there for the thrusters looks all good. height above ground, so that's obviously one we're going to need to check. So here is a good example. Doing a raycast and we're doing a vector 3 up and a vector 3 down. And that's not going to be something that fits for what we're doing because vector 3 down doesn't really make any sense in this case. So we need to do local gravity down. And we would do local gravity up. We also need to be applying the gravity. So the way we apply the gravity, it's actually pretty straightforward. And so what we could do is, so the gravity tracker just tracks it. It doesn't go and apply it. We have to apply it. And it's pretty easy to apply. We do add force. We go, hey, gravity tracker. And, sorry, local gravity. Dot gravity vector. And our force mode, conveniently, there is acceleration. Because gravity is an acceleration. So apply gravity. So we've changed this. These other ones we're using transform right up and forward. That's good. Those will work well. This auto leveling, this is one we are definitely going to have to update. So we're going to put in to do probably broken by gravity. But that's okay. We'll come back and fix it. The auto landing looks okay, although it does have this where it's using the Y component. So that's probably going to need to be updated as well. So we'll chuck in another to do here. And other than that, we can take a look. So things for entering the vehicle looks pretty safe and straightforward. Exiting the vehicle, well, this is another one where down has to be gravity or local gravity dot down. Take a look through for other ones. Everything else looks okay. We can do just a general search for vector 3 dot and just check the different ones that we're doing. So we've got a distance, we're creating a new one. So that actually looks pretty good. We don't have much in the way of ones. So that looks like we've updated everything. So that means as long as our gravity tracker is updating that gravity, we're good. So let's have it that we can control when this updates. Update mode. We could have update, fixed update, or late update. I'm going to then set up a serialize field, update mode, and by default, I'm actually going to default it to fixed update, but we'll check the different ones. So we'll have late update, and we'll also have fixed update. Now I don't need to mark these specifically as private, but what I will do is if update mode is equal to update, then we run it here. So it'll be the same logic in each case. It's just if we're wanting to control and manage the timing of it, that we can easily now do that. How it goes about updating the gravity, it's actually pretty straightforward. So we have update gravity. So what that does is it's going to need to talk to the gravity manager. So we'd go through source in gravity manager instance and all sources. So I would reset the gravity vector to 0. And then all I would do is go, hey, gravity vector, we add source get gravity 4, and we give it our position. That's all there is to it. If we've got things coming from multiple directions, that's good. This will give us the combined gravity. It's not something where we need to average it. We can just add all of the vectors there together. So this, nothing should really change. Moving along the ground here, everything should actually work fine. So we've got the gravity tracker, all of those things set up. Now this did go and add in a second one. So we'll just remove that, just being a case of timing for when I added in the require component and went back to Unity. So let's test this. We're expecting I can wander up to the spaceship and largely nothing's changed. It should fly exactly as it did before without any issues. So everything still works. Now we notice altitude is now kicking in. So that's something where it does seem like something is off with our height above ground calculation. So that is something we do want to go and check for where it's actually grabbing the height above ground. So we just make sure. So that was going up a little bit and then using this. We do want to make sure that it's got the right direction for that gravity. So we will just put in a breakpoint here, and we will just run this and check a couple of times, just make sure that the vector, and I know what it is, our vectors up and everything should actually have been normalized. Easy to miss. So we need to fix this being normalized. So if we go over here, what we'll end up doing is we'll make it that these are all things that are actually set, and do this. So what happens is down is going to be gravity vector normalized, and up is negative of down. And then what we should now find is when we go and run this, that fixes up the altitude offset that was happening. Run it and we see altitude is back working. So everything is working as it did before. Nothing has really changed. We can move around, we've got auto landing, all of that is behaving exactly as it was. But we've just gone for regular gravity. Let's now switch it so that rather than having this set up, we want to have that we have our actual sphere. So I'm going to turn off the ground. What I will do is the global source, I will put that on the ground, and I'll remove it from the gravity manager so that when I turn off the ground, the global source is turned off as well. So for adding in this sphere, what I'm going to do is I'm going to actually use ProBuilder for this, because ProBuilder will let me make a more detailed sphere essentially. So I'm going to make the pivot in the center, and I'm just going to put this wherever, and then manually update the settings here. So its size, it's going to be 1,000 by 1,000 by 1,000. I will position it at minus, I think it works out as 501.6. Works out as the right spot. And then subdivisions, I want there to be a lot more entries for it. And I don't think I can make it any higher. No, 5 is the highest it'll let me do with that. So this is going to be the planet. This gets a gravity source spherical with the gravity set to 9.81. We'll also set up a material for it as well. So we'll go for Mat Planet 1, and we'll apply that via ProBuilder's material editor. It's just going to work a lot better. That is something to remember if you are applying materials for ProBuilder things. Do go through the material editor. You will find it works a lot better. So then that, we've got the base map. Now we don't have much in the way of visible variation with that. So we might be able to find we need to up the tiling potentially a lot. Might also just be the UV coordinates are not particularly working well on this. So we probably do need a better texture for this. but that's okay. It does at least give us a... Oh, okay, there we go. Now we can see it. So it's actually too high a tiling. There we go. That's going to make it a lot easier. So now we're going to find the bits that break. Now the character motor, I haven't updated it for working with this. And the character motor updating for the gravity being variable direction, that's something I will cover in a separate video. I will directly make the changes just in a quick little cut at the end, but I'm going to focus purely on the spaceship side of things. So what that will mean is the input, I'm going to make it that we default to being on the spaceship. And what I'm going to do is I'm going to run it and we're going to just see what breaks. And an answer is going to be quite a bit. So I can move and, you know, I do land back down. Okay, that's fine. What happens if I go and try and auto land? It manages it. It's doing okay. Now I'm in a pretty ideal location there for it. But what happens as I move around? Like, how well does that go? Because what we'll probably find is our auto leveling, and we're starting to see it more and more. Notice how our angle relative to the planet is changing because we're auto leveling based upon world coordinates. So now when it goes to auto land, it's probably going to have a bit of a tough time. It's probably going to go pretty badly. Yep. Not the most successful of landings. So there are improvements that we know we need to make to this. Pretty resilient spaceship though. So that's a positive. So there's improvements we know we need to make. Autoland is going to likely need some updates. Our auto leveling is definitely going to need some updates there because we made some assumptions here with being able to rely on using the transform up directly like that, and that works when it's a case of, you know, we are moving in a space where the ideal transform up for level aligns with the world's version of that. So we need to actually change how we calculate this. And it's not too much of a change, actually, because what we're looking at is our leveling vector is based upon the up we currently have versus the up we should have. And so that's actually pretty straightforward for us to get because we know the up we should have is our local gravity up, and we can just subtract from that transform.up. So that should give us auto leveling that is actually going to kick in and work appropriately for regardless of where we are on the planet. That's actually all it should need change-wise is that. So it just means that it's always going to be based upon our current sort of relative gravity. So let's test this out. How auto landing, there'll be some updates for that as well. So we're not expecting auto landing to work well yet. But what I am expecting is that if I zoom around the planet, that my angle relative to the planet stays pretty consistent. And we can see it is staying pretty consistent. And that's good. So we're auto leveling based upon our local gravity. Now we'll probably find the camera, and we can see the camera is definitely not working super well. And that's okay, because again, the camera was being set to align to world up. So we can land a lot more effectively now because we're always aligned to the ground. So that's good. Now I am going to make a change to the camera. So this was, for the body, it was locking to target with world up. What will probably work better is just doing a straight lock to target. And we can try with that. We can also, so we've got no roll or just a lock to target. So we'll give it a try with lock to target, no roll. And we can test, if we hit solo, can see how these different ones look. Now, can't really tell much of a difference at this point for where it is, but what we could do is if I position the spaceship so that it is somewhere else. So I'm going to just bump the priority of the spaceship camera up, and then I'm going to relocate the spaceship to, and I worked out some coordinates for this. So if we go for minus 500 and 500, then we take a look in the scene view where we are. We're here. Set our rotation, and I think we need to go plus 1.6. So that's good. So we can check game camera with that. That looks still pretty good. That's with no roll or lock to target. They both look pretty similar. So we'll go for no roll to start. And I will position the spaceship back where it was. 0 and 0. That's good. So we want to tweak the auto landing because that is one where we were using just the y component of the velocity there when we want to actually get the, in this case, the component of the velocity along gravity. So our current velocity, now to get the velocity along an axis, we project it, which is the way we do a projection is using the dot product. So if we do a vector 3 dot dot and we project, and what we're doing is our rigid body's velocity, so linked RB velocity, and we project that along the local gravity up. That gives us the component along that axis. So then what I do is I subtract current velocity. That should mean the auto landing works happily for with the variable gravity. So let's test this out. What I want to be able to do is I want to be able to zoom around to the other side. Now the collider, because it's a mesh collider, and the mesh is not super detailed. If you end up on an edge, it can be a little bit messy. But we're happily zooming along. And I want to go till our y is fairly negative. Just so we're giving this a decent test. We can already see our z is pretty large. So we've moved a fair distance away. We're still orienting really nicely with this. You can see we've now gone into shadow. So I'm going to slow down a bit. And then I'm going to just test that it can auto land okay. Turn on the auto land, so it's still managing to land nice and successfully. So we can adjust exactly where we're hitting if we need to, and it lands. No damage taken, which is good. So we've got it working there with the gravity. And the other thing I might do is I think the gravity tracker, it could be good for it to do the updating potentially of the actual gravity. So I'm going to give it the option apply gravity is equal to true. And then in our spaceship, where we were doing the add force, I'm going to move this over so a gravity tracker can apply it if we wish. So if apply gravity, then it will do that. And it will then also need a linked rigid body, which that I will have it that it is something that can be specified. So rigid body linked RB. Just as a way of having it that it can be a bit sort of more easily managed so that the spaceship just needs to query it, doesn't need to apply it. So the spaceship has our gravity tracker on it, we will link up the rigid body and let it apply. And I'll just update our prefab here. So the rigid body changes should apply, the spaceship changes should apply, and the gravity tracker plus any of the bits for the camera. Because we do want to make sure those camera settings are up to date as well. So that looks good. We don't do an apply on the Pro Builder ones. I do find that that can tend to cause issues at times. So if we run it with that change, we are going to actually notice an issue. And we'll notice it doesn't manage to do anything. And that's because if we take a look at where gravity was being applied, so anytime we're working with rigid bodies, always fixed update. So that otherwise it just stomps over everything. So we want to make sure we don't do that. So now it should be a lot happier. So that's good. What we can also now do is variable gravity. So our gravity source spherical, well, we can have our max gravity altitude. So that's the gravity at which it's going to be maximum. So anything less than that altitude, it's going to be, we'll call it altitude for max gravity. Max gravity. So anything below that, the thing will experience the maximum amount of gravity. So we're going to make that, let's say anything under, we're going to exaggerate it a bit, 100 meters. And then altitude for no gravity, we will make that, let's say 200. So once we get beyond 200, there is no gravity being applied due to this. And so we also have gravity varies with distance. We're going to default to true. So F, gravity varies with distance, then that's going to do one thing. Otherwise, we do this. So if it varies with distance, then we want to do, and what we can do is we can do calculate the distance that we are. So float distance is a vector 3, distance from us to the particular location we've been given. And so actually that altitude for max gravity, if we think this is a 500 meter sphere, so max gravity actually should be 600 and that should be 700. We could also do something where we have sphere radius is 500, and then that way then these can be configured something that makes a bit more sense for us. So we get that distance. I am going to subtract the sphere radius from it. So then F the altitude, or F that distance, which actually in this case that would be an altitude. So if the altitude is greater than the altitude for no gravity, we return a vector 3, 0. Otherwise, if the altitude is less than the altitude for max gravity, we return exactly what we normally would. Otherwise, well, largely the same, but the strength needs to vary. So what we would do is we know we need to do a lerp based upon that altitude from the altitude for max, the altitude for, well, sorry, it'll be from gravity strength to 0. So we know we need to do a lerp, and we do have to lerp from our max gravity to essentially no gravity. We need a 0 to 1 value based upon that altitude. So what we can do is a mathf inverse lerp, and we give it, well, in this case, altitude for max, altitude for no, and the current altitude. So I'm going to put that in a separate variable, and I'll call that the altitude factor. And that gives us our strength. So gravity strength changes to that. So now we should have something where the gravity varies based upon our altitude. And what I'm going to do is I'm going to just make it that for now, gravity vector there is just fully public, so we can actually see what that looks like. Now that does mean that we're going to be able to get to a point where we have no gravity. And that might require further updates alone. So we've got the spaceship here. You can see we're tracking our gravity. So I'm going to climb up. And we can see the gravity is now decreasing pretty rapidly. And we notice also our speed is able to go way higher because we don't have gravity and we're not falling. And our speed doesn't decrease or change because we are outside of gravity, which is what should happen. And we'll probably find, now I am decreasing altitude, so we'll hit a point where gravity will start to kick in again, and this will be something where I want to keep an eye on that y value and potentially heavily start applying vertical thrust once we get to a reasonable height. Now there are specific equations for how gravity varies based upon the height above something and tied into the mass. So we can actually use the proper equations there if we want. They're not super complex, so that will be something where once we've made sure that we can safely land, or at least as safely as my usually not super coordinated version of landing looks like, we'll be able to be doing that. Now, we also might need things where like our auto-leveling and that has specific stuff where if the gravity is 0, and we can see our landing camera is, we're getting closer, which is good. So I'm going to just start managing the speed a little bit more because as we get closer, we don't want to be, we will hit the point where gravity starts to kick in. So we don't want to be descending too fast. Now, gravity would actually extend a lot further out than this, and that is something we will factor in. So I'm just going to slow down a little bit more, getting very close to gravity kicking in. We should start to see it ramping up very soon, and we can start to see that, yep, it's ramping up. We're aligning, it's pulling us in towards the planet, and we do need to manage our speed a little bit more. If we auto land, we can gently touch down on the surface of the planet. So there would be some things like the auto landing and that what I would, well, the auto leveling that I would turn off if the gravity is effectively 0. But that worked pretty well. That quite happy with. I will chuck in a thing for the spaceship here, where this is going to check and vector3 dot, sorry, our local gravity, and we will go for the gravity vector magnitude is greater than min gravity to auto level, just so we make sure we have to actually have some gravity for auto leveling. Otherwise, that's something where it's going to potentially start trying to align to a very invalid vector, and that would be bad. So we're just going to make it that minimum gravity has to be at least a meter per second squared for it to try and auto level. We could go lower, but I think 1 is sufficient. So that looks good. Okay, so one of the final things we want to do is we want to make it that the planet, we've got the very simplified variation of gravity with distance. We want to make it that we can have an actual proper sort of planet simulation. So I'm going to have an enum, e mode, and we're going to have constant. We're going to have linear interpolation, and we're going to have, well, actually, kind of a full simulation, probably the better, more accurate term for it. So then we'll be able to set the mode, which will get rid of this setting, because what it would be doing is here, if the mode is not equal to constant, then we go and actually check this stuff. So these are going to be, we'll call this simplified. So simplified gravity. And then we'll have full simulation. So for the full simulation, a couple of things we need. One of the things is we need the planetary mass, and I'm intentionally using a double here for this. So planetary mass needs to be something that's sort of appropriate. So if I set this to the Earth mass, it's going to be way too high in our case because of the size of it. So this is how you specify something that's from scientific notations. This is 5.98 multiplied by 10 to the power of 24 kilos. We also need the planetary radius, which again I'm going to put in the Earth value. So 6.38 E6. So again, that is in meters. The other thing I need is I need the gravitational constant, or gravitation constant, which that is 6.6743015 e to the minus 11. So whereas these are very big numbers, this is a very small number. So then what we do is down here, we have to calculate, well, the setup, we'll actually go and change this and we'll reorganize this a little bit. So if the mode is equal to constant, I'm going to just return this. If the mode is equal to simplified, and we don't need to do an else because it's just going to return with any of these or otherwise fall straight through. And we'll check if mode is full simulation, and otherwise we return 0. So we still need the direction. So the direction vector is still important. So we would have vector 3 direction. It's like that. But we need to calculate the strength. So the gravity strength, which I'll do, doesn't actually, it can go back to being a float, I think. Gravity strength. So we take our gravitational constant, we multiply that by the planetary mass, and we divide that by, well, it needs to be our radius plus our distance. So we have our distance that we are actually from the center here. So we would grab that. So we're going to be assuming that we're actually getting back a full distance here. So we would go distance from center. So this does mean our distance from the center, we're expecting that to actually be potentially a very large number. So floats might not be ideal for that, but the vector3 distance is only going to give us it back in a float. So I'll just call that distance. We don't subtract the radius. So we would do this times this. So it does actually mean we don't need our planetary radius. Now you'll notice this is calculating it all as a double and we're putting it into a float, which means, and I will do the conversion last because we don't want it to be adjusting it beforehand. So then what we would have is direction by gravity strength. Now this distance here, oh, and we lost the altitude calculation up here, so we will just bring that back. Minus the sphere radius. So we could have something where, we are biasing the distance, but with a full simulation, you kind of just have to rely on it's actually positioned that far away. Now, we are positioned a fraction of that distance away. So the Earth radius is, a many orders of magnitude higher than our actual radius here. So what we're going to need to do is our planetary mass is actually going to need to be reduced quite a bit. So if I go full simulation, that planetary mass, so if we think about it in terms of how the stuff's used, our distance is 6 orders of magnitude less. So to get kind of an equivalent gravity, we need our mass there to actually, especially because it's squared, to be 12 orders of magnitude less at least. So I'm going to change that to be much lower, still a very high value, but it is much lower. And what I've also done, just to make it, to keep it a little bit easier for working with the gravity, I've set this so that it's public for now still. So let's take a look and see how that goes. We might need to tweak those values further because we are working with stuff where we're using actual calculations now, and we can see the gravity force there is still way too low. So we probably, what we can check and see is, okay, the planetary mass, what if we increase that? And I have just increased it by 1,000-fold, because that should increase the gravity. So higher mass will give us higher gravity. We can see that's better. And I think if we increase the gravity, probably by about 6-fold, which makes sense. And let's see how that looks on the spaceship in terms of what that gravity we're getting is. So it's still pretty low. We can increase the mass a little bit further. So I could make that 16. That should give us a bit more gravity for it. This is the thing with a full simulation, so that's now a bit too high. So we would then go and make one more change. I might make that 3. Probably going to get it pretty close to our default sort of Earth gravity that we're wanting it to have. So it's a very dense planet. That's pretty good. It's a little bit lower than Earth gravity, but we still get that variation with altitude. The difference is that now that variation is based upon the actual mass of the planet. So if we had something that was very light, it's going to work quite nicely. So that's good. What we can also then do, now this is something that I'm not expecting this to work nicely, and is something where we're not going to try and fix it now if it does break as hilariously as I expect it to. But if I have this as planet 1, and then I'm going to have planet 2, and I'm going to position that quite a bit above. So we want to make sure definitely that it's not touching like of that. I'm going to make it that it's positioned further above. I'm going to duplicate that material, and we will update planet 2. So it uses this different material, which I will tint differently, like that. So what I would now expect is when I get high enough, I'm actually going to then be aligning to this other planet's gravity. Now I will move it so that it's a little bit further over, like that. Now I'm not expecting this to work perfectly. I'm very not expecting this to work perfectly, because this is something where it's going to now be transitioning between gravity vectors. But that's okay. We can see we're already actually experiencing less gravity because we do have that other planet. And our direction, we notice, is shifting as well. Now our speed, and this is the challenge when you've got another planet, but we did get pulled in by that other planet. It also helpfully exposed that we need to make sure we do a couple of updates here so we're properly checking that we actually still have a spaceship. So vertical thrust only makes sense because it might not have been able to eject the player from it. So we're just going to do a couple of little bits of safety checks with the spaceship, which that's something where we could also check if the spaceship is alive, just so we're making sure that we're not sending stuff through to something that has been destroyed. The destruction is kind of to be expected there. It was definitely going to not be particularly happy. We can also make sure the HUD is updated as well. So if the linked spaceship is null, we do nothing. So a couple little safety checks in there to make sure that works. So we fixed up those couple of crash things we did run into, so that's good. Now, doing the actual transitions to the planets is going to be tricky. And the reason it's going to be tricky is because we've, up until now, been very much working on the basis of having pretty simplified setup for our cameras, things like of that. So what I'm going to do is just actually position the planet a little bit of a distance away. So I'm going to position it here. We might make it that it is, that's actually probably okay. And I'll position it so that I'll lower its gravity just a little bit, not a huge amount, but a slightly lower gravity. Because what we want to confirm is just, can I do a transition between them? And things like the camera, I know that's going to be something that needs improvement. And that's okay. What I will do is that will then be something that I go and adjust. And we'll focus on in another video is looking at how can we adjust the camera? How can we give ourselves a bit more roll control? Because we've very much damped the rolling and pitching movements of the spaceship, intentionally so. Like that was something that we very intentionally dampened those. So we're a little bit lost in terms of where we are. We're on the far side of the planet now. What we want to do is head, I don't know where the red one actually is relative to where I am. Where's the spaceship? Very far away from the red planet there. So I'm going to make it so that it's a lot easier to actually see where the red planet is. And I think that needs to be something like, there we go. So we're going to head directly towards that and see what happens. So what I'm expecting to see is the spaceship at the moment is aligning with the green planet. When I get close enough, I expect it to start aligning with the red planet. And we can see it's now tilting and it's aligning to that red planet. Now its velocity is very, very high because we started moving very, very quickly. I'm going to slow it down. What I want to be able to do is just come into a landing on the red planet. Landing nice and slowly. Now I still will be under the effect of gravity from the other planet a little bit. So this is something where you normally wouldn't have the planets this close, but we successfully landed. So we've got it working that we can switch between different planets, that we can simulate a very detailed version of gravity. And now obviously if we try and the player controller itself needs some updating because at the moment I'll just go and exit and we'll see what happens. It's going to not work particularly well because the player controller does not understand spherical gravity. So immediately with the player controller, it's going to end up moving around and it'll largely stick to this, but we would hit a point where we would fall off of the side. And in particular, if with this we went so that we are over towards the other planet, it would actually be quite hilarious probably what would happen. We would end up having some serious difficulties with it actually the player managing to move appropriately. And that's okay. We expect that, and that's something that in a future video we'll update. So the player is here and we can see it's definitely a case where we can jump and that seems to be working okay, but we will hit a stage where it ends up going a little bit weird and we would end up being able to fall off the planet because we don't actually have the correct movement. And we can already see as I jump, I'm starting to end up falling long, long, long distances. And yes, in this case, okay, managed to still come back to ground, but that probably won't be the case for much longer. Yeah, it's not going well for the player in that case. So I will, in the version of this that goes up into the repo, I will add in a version of the character motor that's been updated. And there will be a separate video that looks at the updating of the character motor. But we've got our spaceship being able to handle different gravity. We've got a system for being able to simulate gravity, where it can be planet-based, where it can be simplified, where it can take into account gravity from multiple directions. And so next time we'll look at updating things like the camera and improving our roll control so we can more smoothly do those transitions. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, really helps out, really appreciated. If you've got any questions, chuck in a comment below. If you're looking for the code is available up on GitHub and there's a link to that in the description and you can use that code any of your own projects, commercial or non-commercial ones. And if you are looking for finding more of the videos, there is also a link to the video archive, which has all of the videos there that's searchable based upon keywords, descriptions, things like that. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description below. But until next time, bye.